Pre-Algebra. This is lesson 32B, and we are almost finished with the school year. I want to read from Psalm 96. I will be reading verses 1 through 4, and we're going to focus on verse 2, which I would want you to go ahead and write down. It says, "Oh, sing to the Lord a new song, sing to the Lord all the earth. Sing to the Lord, bless his name, tell of his salvation from day to day. Declare his glory among the nations, his marvelous works among all the peoples. For great is the Lord and greatly to be praised. He is to be feared above all gods." So this is a wonderful passage, and we really could have written the whole thing out, but I didn't want you to necessarily have to write that much if you did not desire to. You certainly could, but the emphasis here is on worship, worshiping him, singing, it says, blessing his name. But it's based out of what he has done this time. It isn't always, but in this psalm, that's the emphasis because it says, declare his marvelous works, or declare his glory. Declare his marvelous works among all the people. And we're to tell, verse 2, of his salvation from day to day. So the bottom line in this psalm is that we would declare his works. And also his salvation. Two things there. And now we can't declare what we do not have. Right? So the first thing would be to provoke our hearts to seek him. If you don't feel that you understand his salvation, if you don't understand it scripturally, if you don't understand it relationally, what he has meant in your life, where you have experienced his forgiveness and, truly being able to respond in faith to that, where you have experienced his hand, his works, his answers to prayer, where you have seen him at work in the lives of yourself and your family and your friends and those around you, then the implied part is that you want to seek him. So you want to declare it, but if you don't have much to declare, you want to seek him until you do. So seek him. Ask him, Lord, give me a testimony. Give me something to declare. Open my eyes that I recognize, that I see you in my life, that I see you active in my life, that I see you responding to my pleas and changing my desires and changing my life. Give me a testimony. And as you have a testimony, every part of your testimony, not just when you became a Christian, maybe one time long ago, but how he is active in your life every week. I believe God wants us to have a testimony actually daily of how he is at work in our lives, what he is teaching us, what he is doing for us, how he is showing himself strong, our great provider, our great fountain of wisdom, etc., etc., etc. So let this scripture provoke you to know him better, that you might proclaim him more. In Jesus' name. Now we're going to go ahead and read your answers that you've done for homework. So if you need to go collect your materials in your book, go ahead and do that now. And then we'll begin. We're in the second part of this review, the sharpening skills, and we're going to read 1 through 25. Number 1, hexagon, then triangle, then octagon, then pentagon. Writing the definitions, just make sure you know each of these supplementary angles. Sum to 180 degrees. A vertex is the corner of an angle or a triangle. Isosceles triangles have two sides equal. Scalene triangles have no sides equal. A circle has all the points equidistant from the center. A polygon is a two-dimensional closed figure or closed curve made up of straight lines. Congruent angles are angles that have equal measurement. A trapezoid has two parallel lines, and then the other two lines are not parallel. So there would be the parallel lines right here, and the other two are not parallel. Okay, something like that. And that's it. Okay, so it says for 13, write the number of degrees in the complements and supplements. Complements, remember, add up to 90 degrees, supplements to 180. So number 13, your two answers are 55 degrees, 145 degrees. Next, 1 degree, 91 degrees. Next, 68 degrees, 158 degrees. Next, 40 degrees, 130 degrees. Find the perimeter, number 17, 58 centimeters, then 5.25 feet, then 24 inches. Find the area, beginning with number 20, 90 square yards, then 314 square inches, then 63 square millimeters. And finally, the last three, review ideas. Number 23, prime factoring, 2 to the third times 3 to the squared. Break it down to primes. You can do it by a tree or however else you want, and then write it with exponents. So that would be 2 to the third times 3 squared. Number 24, find 7 and 1/8%, and you're going to multiply by 0.07 with the fractional part after that, the 1/8, and you will get 26.79. And finally, canceling out there to simplify, you will get 5b cubed. If you need to go back and review those common decimals, fraction decimal conversions, please do. All right, number 8.37, we're talking about the surface area of a square pyramid. So recall, when you have a square pyramid, you are going to have a base that is a square, and then you're going to have 4 sides that are all triangles. So you have a base, the area of the base, plus the area of 4 triangle sides. So our first one will be 77 square feet, then 44 square feet, then 391 square inches, then 576 square feet, then 144 square inches, then 95 square feet, then 275 square inches. When we're doing our problem solving, the answers will be 480 square feet, then 1,525 square feet, then 216 square feet, then 12 square yards. Let me do a couple problems by way of review. We'll begin with number 2, and our base is 2 feet, our slant height is 10 feet, and we want to figure out our surface area. So the surface area of the base will be 2 times 2, or 4 square feet. And the surface area of one triangle will be 1/2 times the base times the height. Right? And those two will cancel out, so you'll get 10, and then you have 4 of them. So that will be 40 square feet. Add these up together, and you're going to get 44 square feet. And that's how you do all of them. Okay? And as we look at the problem solving, they're all for the same. They're just finding the surface area of a pyramid with a square base. So there's nothing different about those than what you've done in the section above. Now let's look at 8.38, surface area of a cylinder. Now when we think about the surface area of a cylinder, Little bit harder perhaps, but what you've got is you've got the area of a circle on the top and the bottom, and then you're going to slice the side of the can open, so to speak. This will be, if this is your height and this is your radius, right? The height will stay the same, and this will be the circumference, right? As you open up the can, so to speak. So now reading your answers for finding the surface area of the cylinder. Number 1 through 8, 753.6 square inches, 408.2 square inches, 75.36 square inches, 62.8 square inches, 803.84 square inches, 188.4 square feet, 301.44 square inches, and 791.28 square inches. For the problem solving, we have 471 square inches and 61.23 square inches. And finally, for the sharpening skills, we have 620 square feet, 376.8 square inches, 225 square inches. Number 4, 486 square feet. Number 5, 320.28 square inches. And number 6, 336 square feet. So I want to do number 2 by way of review. We have a radius of 5, a height of 8, and I want you to tell me the surface area of the cylinder. So we have a top and a bottom, and that would be the area. What is the area of a circle? Pi r squared. So 5 times 5 is 25 pi. Whoops. 25 pi. And that would take care of the top and the bottom. You want to add to that the area of the side, the circular side, and you cut it out, and you're thinking what? Height times circumference. Circumference is 2 pi r and height, right? And so this would be 2 pi, r is 5, and height is 8. So if we do a little math, we end up with 25 times 2, is 50 pi, and we're going to end up with 40 times 2 plus 80 pi. All of that together will be 130 pi, and this is the way I like to do it. I don't like to grab my calculator to the very last step. So let's grab my calculator and convert that to a number. So for our problem solving, they're both the same, surface area of a cylinder. For the others, the sharpening skills, we need to think through what our formulas are. For a rectangular prism, to get the surface areas, that would be 6 surfaces. Surface area of a cylinder, we've just done that above. Lateral surface area of a cube would be 4 sides, 4e squared or 4s squared, however you want to think about your variable. Surface area of a cube, that would be 6 times one side, which is 6s squared or 6e squared, if I'm thinking edge versus side. Surface area of a cylinder, we just did, and surface area of a pyramid, we call that with a square base. You find the area of the base and 4 triangles with the slant height. Okay, now we're ready to go on to some new ideas. First off, we're getting ready to do volume. The first thing you need to understand now is that both surface area and volume are based on or are regarding 3-dimensional figures. Right? The difference is what? If I'm thinking of a rectangle here, the surface area is the area on the front, the area on this side, the area on that side, and then you multiply each of those by 2. So you've got 6 sides, and we're taking the area of each side. And so our answer is always in square units. Now that's by way of review. How does that contrast with volume? So for volume, we're going to think the area of the base, but it's 1 unit high. Okay. So all the little blocks I could fit in that base up 1 unit. And then how many units high is it? This one has, like, you could think of 4 layers. So it would be, however, you take what's at the base and you'd multiply it up however many layers you have. And so my answer is in cubic units. Does that make sense? Let me say one more idea about that. Another way to think about this is if I have area, it's how many little blocks can fit on a piece of paper. If I have volume, it's how many, let's see, how would I draw that? It's how many little dice would fit. Does that make sense? And then you would increase it by the number of layers you have. So this represents area, this represents volume. So now that you understand the ideas, the formulas will be probably very obvious. What if I have a rectangular prism? As I drew in the first diagram above. Well, if I have a rectangular prism, I would multiply length times width to get the number of blocks in the, or dice or whatever, in the base, and then times the number of layers. That would be the height. So volume equals that. So the big thing is you want to make sure you know what we're talking about as far as picturing the shape in your mind. Don't get confused on the vocabulary. So if we want to find the volume of a rectangular prism, if its length is 14, its width is 9, and its height is 12. How would I do it? I would simply multiply length times width times height, or 14 times 9 times 12, multiply it out, and your answer will be in, you'll get 1512 if you used a calculator to do that, and your answer is in cubic feet. Make sure that you understand the difference between that and square feet. So the other thing I want to do is talk a little bit about exchanging units. We've covered this one time, but now we're in cubic rather than in area. Changing units in area, and now we're in changing units in cubic, okay, or volume. So if I have 4 cubic yards, how many cubic feet would that be? Well, how many feet are in a yard? Because I'm changing to feet. I have 3 feet in a yard, so I'm going to have more. So I'm going to need to multiply. Right? And because it's cubic, I don't use a multiplication of 3, but I use a multiplier of 3 times 3 times 3, or 27. So I would figure out my answer by taking 27 times 4. And I would be 108 cubic feet. Let's do one more. To move from inches to feet, I have 12 inches in a foot, so I will have less because feet are larger units by 12. But not just by 12, because it's cubic, I'm going to divide by 12 times 12 times 12. 12 times because it's cubic, right? 12 times 12 times 12 is going to be 144 times 12, or 1728. And I'm going to take this number, divide it by this number. I could do that on the calculator, and I'm going to get 0.5, or 1/2. So I think you should be able to do the rest of those on your own. And now let's go to how would I figure out the volume of a cube. The difference between a cube and a rectangular prism, of course, is that every side, the length, the width, the height, this is supposed to be a 5, is the same. So how do you think you'd do it? Well, you'd figure out, this is the way I like to think about it, you figure out the area of the base, which is 5 times 5, and you're going to multiply it by the number of layers, which is also 5. So the formula would be the edge or the side cubed. That's my formula. 5 times 5 is 25, times 5 is 125. And if these were in feet, let's say, then the whole thing would be cubic feet. Now the third idea is the volume of a square pyramid. Now recall that if we have a square pyramid, there we go, something like that, I'm going to have the area of the base. Now we could imagine if we had gone straight up, we'd do it times the number of layers, but that would not give me a pyramid. That would give me a rectangular prism going straight up on all 4 sides, right? Oh, that, of course, missed the side there. Okay. But I have a lot less than that because, oops, I didn't want to do that. I have a lot less than going straight up because it's coming to a point at the top. So each layer is getting smaller and smaller. Can you picture that? This, whoops. Got to get off my eraser. The first layer would be that big. The 5th layer would be smaller. You see down to a tiny little layer up top. All these little rectangle layers until you get to just a point. So it's actually 1/3 of what it would be if I went straight up. Isn't that maybe a little surprising to you? But it's 1/3. So, but it sure makes the formula easy to remember. The formula for a rectangular or a, actually this is a square pyramid, is going to just be length times width times height. That would be for a rectangular prism, okay? And you're going to take 1/3, and that's my formula. So it'd be 1/3 times length times width times height. Now, of course, if it's rectangular at the base, my length, width, and height are all the same. So I could have said 1/3 times E times E times E, or E cubed. Either way, they typically just write it this way, which means that if I'd extended my base to be a rectangle, it would be the same formula, all right? So let's go ahead and give you a sample problem here. Actually said that a little bit wrong before. The length and the width would be the same, right? But not the height. The height's going to depend on how high the pyramid is. All right, so now that I got that straight, let me give you an example. So I'm going to have a very skinny, tall pyramid here, and I'm going to figure out go ahead and put down your volume. Your formula equals 1/3 height times base, right? Or length times width, which are the same. Go ahead and do your division ahead of time. 3 times 3 is 9. 9 times 6 is 54. My answer is always cubic inches. By the way, something they don't say right off here, but always make sure that this unit and this unit are the same, or convert them before you begin something like this. And I believe that is all the new ideas we want to cover today. Let's talk about your homework. So your homework should be fairly straightforward on these volumes here, and then we're going to have a quiz that I will attach, send by email, and you want to make sure you have that finished by next Tuesday is the day you're supposed to come to Hoffmantown, next Tuesday, which would be 5/5, and your parents have received an email regarding that. It'll be next Tuesday morning at Hoffmantown, and the time is on the email. Make sure you come because you want to pick up all your papers, turn in all your papers, and don't forget that this is week 32 next week, and the review and the final exam. So you want to make sure you have your papers back so that you can do a good job and finish well.